Everybody, Mr. Smith here, and in this video lesson, it's a review lesson, and we're going to review some grade 9 concepts relating to linear relations. Before we start, if you guys could hit that like button, smash that subscribe button. I'm just kidding. I've just always wanted to say smash that subscribe button. All right, enough fun. I'm a dad, so I got to throw in some dad jokes every now and then. If you don't find them funny. But let's get started. Enough rambling. We're reviewing linear relations. Let's get going. So to review linear relations, maybe we should actually talk about what a relation is. So in your grade 9 course, you would have learned that a relation, it's just a relationship between two variables. And often in math, we use x and y. And in this warm-up, so just kind of getting started, we're going to look at 4 relations. We're going to look at some relations 4 different ways. So I call this the rule of 4. So you can describe a relation 4 ways. You could use an equation, a table of values. You could actually write out the rule in words, or you could use a graph. And so, especially in like now that we're in grade 10, the grade 10 academic course, we're definitely going to see a lot of equations. We're going to make tables of values. We're going to do a lot of graphing. We don't always write out the written rule. We'll hopefully be quite competent at reading an equation and understanding what it says. But let's look at 4 relations. And so you can do these along with me, but if you get the idea, you can work ahead. That's fine too. So here's our first relation. The equation is y equals x. So for this relation, the written rule is, what this equation is saying is that for all the points that satisfy this relation, the y values equal the x values. So that's a way to describe that equation in words. So we're going to create a table of values now, and just find a certain number of points that kind of help us see the shape of this graph, what it might look like. So I've chosen to go from -3 to +3, and this is just like by default, it's a safe choice to get you a few easy points. It's not a rule like you have to do -3 to 3 or you have to use 7. I just made those up. But often using a few values around 0 is a good choice for the x values. So what are the y values? How can we use this rule to get the corresponding y values and generate a graph? Well, use the rule. The y values equal the x values. This might be the easiest table of values to make of all time. The y values equal the x values. So when x is 0, y is 0. When x is 1, y is 1, etc., etc. That has given us 7 points that we can draw on this graph. So let's do that. If I could find where my cursor is. So x-axis, y-axis, let's plot those points. So -3 is here. -2, -2. -1, -1. And as is often the case, when you're graphing a relation, you'll see a definite pattern. And here, this is definitely looking like these points go up in a straight line, 2, 2, and 3, 3. Now, if you're at home and you've got this printed off, or if you're marking up a PDF on your computer, you'll probably have a straight line tool. I don't necessarily have a straight line tool, so I'm going to rough this straight line out like so. But yeah, I mean, this relation y equals x, it gave us this straight line. That's pretty cool. Let's do some other relations as well. Let's look at this next relation. How about y equals 2x? Well, what's the rule for this equation? What's saying the y values are double the x values? Double the x values, twice the x values times 2. They all mean the same thing. But yeah, that's a pretty easy rule to use. Again, I've used just that default standard safe -3 to 3. And so the y values are double the x values. So we can do this with mental math. Just just doubling all those guys. 2 times 2 is 4. 2 times 3 is 6. And what does this graph look like? Again, x-axis, y-axis. I'm throwing those in there not because I have to, but I just, it may have been a long time since any of you guys actually plotted points. Have to be able to plot points correctly at this point in our math careers. So x is -3, y is -6. Boom, -2, -4, -1, -2, 0, 0, 1, 2. A definite pattern again, and certainly looks like a line. You can connect those with a straight line as best you can. There we go. All right, decent. Cool. So now that I've done these two, it would be great if you actually could just pause the video and try relations 3 and 4 on your own. Check back in when you're done. But if you just like to follow along, that's cool. So here we have a new equation, y equals 2x plus 1. So here the y values, there's lots of different ways to say this, but we're doubling the x values, then adding 1. So we'll just write that out. Double the x values plus 1. So I'd hopefully expect you guys to be able to see that equation and understand that's what it's saying. And at this point, we're going to generate a table of values using that rule. So when x is -3, so maybe if you need to write out this, that's fine. So we're going to double the x value and then add 1. So 2 times -3 is -6 plus 1. That is -5. If you don't need to write that out, if you can just use your calculator or mentally just get -5, that's totally fine. I'll write out a couple of these just to make sure we're all comfortable. So double the x value, 2 times -2, and the rule says we add 1. -4 plus 1, that's -3. And maybe I'll show one more. So 2 times -1 plus 1, that's -2 plus 1, that's -1. And there's a pattern here. These values are increasing by 1. We're going to get 1, 3, 5, and 7. And if I plot these points, -3, -5, -2, -3, -1, -1, we definitely get a pattern. Again, it is a linear relation because the graph is a straight line. And draw your straight line. That looks pretty good. All right, another linear relation, just getting used to this idea of what a relation is and generating a table of values. How about relation 4? If you haven't done that yet, let's look at this one. This equation is saying, the written rule is saying, to get the y values, you square the x values. The y values are the square of the x values. All right, so this is just a good time to just review with you guys. So when you're squaring a number on your calculator, some of you guys will have an x squared button. Well, actually, I think most of you guys should just have an x squared button. And I would argue any of these values, we should be able to use mental math as well. But remember, when we square a number, you always get a positive number, except when you square 0, you get 0. So what do I mean by that? Well, -3 squared, I'm just going to write this one out. But -3 squared, remember, that's -3. To square something means you multiply it by itself, right? -3 times -3 is +9. So even students in the grade 10 academic course are not immune to this. A lot of students would say, hey, -3 squared is -9. No, it's +9 because you're doing -3 times -3. So in the same way, -2 times itself gives you 4, and you get 1. 0 squared is 0, and then 1 squared is 1, and you actually start repeating these numbers again. -3, 9, -2, 4, -1, 1, 0, 0. But check this out. Now the points are going back up. 1, 1, 2, 4, 3, 9. And we don't get a straight line. we get what we call a non-linear relation because it's not a straight line. And that's what the graph of that relation looks like, y equals x squared. And as you guys proceed throughout the grades, you'll learn more and more types of equations that give you cool different shapes of graphs. But that's for then. For now, what we've just done is we've looked at some linear versus nonlinear equations. The linear relations should look familiar to you from last year. We're going to review that a bit right now. That last relation is called a quadratic relation, and we're going to learn a bit more about that later in our time together. But today we're going to focus more on linear relations, which correspond to the first three. Our first three graphs were lines. So let's continue. So on your lesson sheet, I've got a linear relation for you, relation 5. So I'd like you to graph that one. And I want you to also, once you've graphed it, think about what the slope of that line is. So remember the slope of a line. And you guys last year introduced slope, and we used a lowercase m for slope. M for monter, the French word to climb. Kind of slope gives you an idea of how steep a line is. And our initial definition of what slope was from grade 9 was rise over run. So just look at 2 points. What's the rise? What's the run? Stick them over each other. You've got the slope. And y-intercept is just where the graph crosses the y-axis. And ultimately, what we'd like to do, what you hopefully got proficient at in grade 9, was looking at a linear relation and just being able to pick off the slope and y-intercept right away. But this is a little bit of a review. So if you're okay, you know what, I'll just write out the written rule. The written rule here is the y values. I was going to be lazy, but I thought, no, let's not be lazy. The y values are double the x values, and then you subtract 3. So show my work for the first couple perhaps, but you don't have to if you just got the values. 2 times -3, subtract 3. Well, that's -6, subtract 3, that's -9. 2 times -2, subtract 3. Well, that's -4, subtract 3, that's -7. And the trend here is that these will be going up by 2. -1, 1, and 3. If we plot those points, so -3, -9, -2, -7, -1, -5, 0, -3, and finally 3, 3. So again, it's a linear relation. You can draw a smooth curve through those, a line through those if you wish. But let's talk about what the slope and y-intercept is. And maybe even before that, if you're wondering, well, these days, there's lots of great programs like Desmos, maybe you used last year, but programs where you can actually put in an equation and it tells you all the points and makes the graph for you. We will absolutely make use of those programs a lot, but I actually want to make sure that you guys are all capable, given an equation, can you generate a table of values? That is an important skill, and hopefully after this review lesson, we've reviewed that skill and you guys are proficient at it and we can use technology more often. So back to this problem though. What's the slope of this line? So I might just switch to a different color. So it doesn't actually matter what 2 points you look at. Between all these points, there's like a little staircase, right? The rise, we're going up 2 and then over 1. 2 over 1, up 2 over 1, and in the positive directions, right? So up 2 over 1. So our slope is 2 over 1, but we should be simplifying that as just 2 at this point in our math careers. 2 over 1 is not wrong, but it's not fully simplified. We need to make things as simple as possible. You guys should be writing 2. The slope is 2, and the y-intercept, where does this line cross the... I always lose my cursor. This will be, you guys will see me lose my cursor probably 50 times this year throughout all of our lessons. All right, where does this line cross the y-axis? Well, it crosses the y-axis right there. at the point 0, -3. This is the y-intercept. Now, often we understand the y-intercept is a point. It's the point 0, -3, this guy here. But when we're stating the y-intercept, sometimes we just say the y-intercept, we would just say it's -3. All right, now looking at the equation, can you see the slope and y-intercept somewhere in the equation? So hopefully that's kind of a duh answer, right? But like, yeah, the slope appears here in front of the 2. The y-intercept appears on the end, -3. And you guys would have learned in your grade 9 course that this is true for any relation in this form. The slope is the number in front of the x, the y-intercept is the number on the end. You don't need to graph it to figure that out. We just understand that property. We derived it in grade 9. So here's the key idea, summarizing what you guys learned in grade 9. This is called the slope-intercept form of a line. It's any relation of the form y equals some number m times x plus some number b. It's a linear relation, where m is the slope of the line, and b is the y-intercept of the line. So m for slope, because slope is a measure of how steep a line is, and the French word for to climb is monter. Why is the y-intercept called b? I don't know. It just is. You can't use y. We've already got a y representing the y values. So we just use b. B is the y-intercept. And so hopefully what you guys got good at last year is picking off slope, picking off y-intercept, and actually making a graph of a line without needing a table of values. Like knowing what we know now, we didn't need to make a table of values for this graph. You could read off your y-intercept and plot it, and then use your slope to just generate more points using that kind of staircase. So that's kind of where we need to be. All right, so let's give this a try. So I'd like you guys to, can you pick off the slope and y-intercept for these 3 lines and then graph them on the grid provided? So maybe pause the video, try that, and unpause when you're ready. Of course, it is always okay to just follow along with me, but it is my hope that you're trying these on your own and trying to become a little bit more independent. So I would encourage you, give them a try, but if you want to follow along, that's okay too. So what's the slope of this first line? So -x, what number is assumed to be there? It's -1. We just don't usually write the -1. It's just -x, we understand that that number is -1. So the slope is -1. If you just wrote down -1, that's okay. I'll write m equals -1. And my y-intercept is 5. So to graph a line, plot the y-intercept, 5, and then use the slope to get more points. So -1, that's like -1/1. I'm writing that out to help those of you who might need a bit more help with this review stuff. In terms of a staircase pattern, that means we're going to go down 1 and right 1. So down 1, right 1 gets to here, down 1, right 1 gets to here, and ultimately 2 points are enough to graph a line. But I always tell my students, grade 9, grade 10, when we're graphing lines, just fill up the graph. It doesn't take a lot of time. It makes it easier to connect the dots with a ruler. Of course, I'm not using a ruler, but you guys at home, if you're writing this on a piece of paper, use a ruler. This will work enough for me using a tablet. And because I'm going to have multiple lines on this grid, I'm going to label this one. That's y equals -x plus 5. How'd you do on the next one? The next one has a slope of 2/3, 2/3, and a y-intercept of -4. Don't forget the sign, -4. So our y-intercept, and I think it's easy enough for me just to use a different color. Let's use bright orange here. Maybe a bad choice because I'm definitely going to lose my cursor with this. Definitely going to lose my cursor. So start at -4, plot the y-intercept, and then this slope of 2/3 is saying you go a rise of 2, so up 2, right 3, make a point. Up 2, right 3, make another point. Continue the staircase. That's enough, but I like filling up my entire grid. And then you go backwards using the same pattern. You guys don't be naughty and use a ruler. Y equals 2/3 x minus 4. Give that a label. And then finally with our last one, so what my anticipation is that for the last one, a handful of you might have said there is, I'll use purple here, there is no y-intercept. I'm expecting you guys all got the slope. But I also am expecting a few of you to have written down there is no y-intercept. There is a y-intercept. The y-intercept is 0. Right? This is like 1/2 x plus 0, right? But we don't write plus 0. That'd be silly. So yeah, there is a y-intercept. It is 0. So this guy starts at the origin, 0, 0. And then we do up 1 over 2, up 1 over 2. Fill that graph up. And connect. Oh, that's awful. That's okay. You guys will do better. And that was y equals 1/2 x. So we've reviewed the slope-intercept form of a line, had a graph from slope-intercept. These are things we need to be absolutely rock solid with this year. I give you a line, you guys graph it, easy peasy. So it's okay if it takes a bit coming back, but you guys did do this in grade 9. We've reviewed how to do it. I'll give you a better practice, but moving forward, this has to be something that we can do kind of like automatically without, spending a lot of brain power on. We want to use our brain power for more things this year, not just graphing lines. All right. What you also learned in your grade 9 course is that not all linear relations were in slope-intercept form, and not all relations, period. You can have relations that don't have the form y equals something. So I'm going to give you a relation here, x plus y equals 5. And I haven't given you guys any x values here intentionally. So let's think about this one. What is that equation saying? What is the rule this equation is describing? Well, it's saying that x and y have to add to 5. Any combination of x and y that adds to 5 satisfies this equation and is a point on our graph. X and y add to 5. So can you think of some numbers that add to 5? Well, I'll give you some easy ones. 2 and 3 add to 5. So when x is 2, y is 3. But I could flip that. When x is 3, y is 2. Those add to 5 and that works. 0 and 5. Or 5 and 0 add to 5 as well. Can you come up with 3 more? They can be negative, positive, whatever you want. Again, if you just want to follow along with me and use mine, that's okay too. I'm going to mix it up. If x is -2, well, -2 plus 7 gives me 5. That works. If x was 9, I'd have to do 9 take away 4, or 9 plus -4. So 9 and -4 would work. And I anticipate many of you guys probably used 1 and 4 as a combination too. But we don't need to find every single point. In fact, it'd be impossible. There's infinitely many. Those will be enough to hopefully see what this graph looks like. Let's plot it. So there's 2, 3, 3, 2, 0, 5 is here. 5, 0 is here. -2, 7, 9, -4, and 1, 4. Well, look at that. All these points definitely look to be on the same line. That's because this relation actually does give you a line. It's just not in slope-intercept form. The slope of this line, well, as you can see, between each point, we're going down 1, right 1, down 1, right 1. So we're going down 1 for the rise and right 1 in the positive direction. So that's a slope of -1. And the y-intercept we can see is 5. So the idea with this final little mini investigation is that a linear relation doesn't have to be in y equals mx plus b form. It could be in this form or other forms as well. So we're going to do a few things with that right now. So let's say we wanted to graph a line. As we just saw, Not every linear relation has to be in our y equals mx plus b form. This relation was a line, and the next one's a line too, and we'd like to graph it. So how can we do that? So the first method that you guys learned in grade 9 was, well, you could just make it into y equals mx plus b form and graph from there. And this is using the rearranging tool. So it's the same kind of skills as solving an equation. So let me show you what I mean by that. So ultimately, we want to get y equals mx plus b. So we need to get that y by itself. So right now, we have a couple terms that aren't y stuff. We have a 2x and negative 12. So we're going to use opposite operations. So I would add 12 to both sides and subtract 2x from both sides. Now, you can visualize it, many different ways, but I'm just going to show an alternate way here. We're going to move those terms that aren't y stuff to the right-hand side. So we're still left with negative 3y. Don't forget that sign. It is negative 3y. And when you move something across the equal sign, it changes signs. So if we subtracted 2x from both sides, we'd get minus 2x over here. And if we added 12 to both sides, we'd get plus 12 over here. It's the same as if we just pick these guys up and move them over and their signs changed. Again, this is something that you guys would have learned in previous grades. We're reviewing it right now, and in the future, we might just move a little bit faster. That's almost in y equals mx plus b form, but it's negative 3 times y. Well, let's just divide everything, and I mean everything, including that constant term on the end. Divide everything by negative 3. And we're done. We get negative 2 over negative 3. Now, that is correct, but it's not as simple as we can make it, because a negative divided by a negative is a positive. So we should be writing that as positive 2/3 x. 12 divided by negative 3 is negative 4. So we've rearranged this guy into slope-intercept form. And we could graph it. Now, before graphing it, I like to actually do method 2 and show you we get the same graph. So again, we could graph this from there. You know what? Let's just graph it. Call an audible here. Let's just graph it. So 2/3 x minus 4. You guys have this on your sheet. I just got to flip back to make sure I have it. 2/3 x minus 4. Plot the y-intercept. Slope of 2/3 up 2 over 3, up 2 over 3, up 2 over 3. I like filling my graph up. Oop, that was not the right point. Erase that. There we go. Down to right 3, or down to left 3 if we're going backwards. All right. So we've graphed our line. If you have a line that you need to graph and it's not in y equals mx plus b form, guys, you could just put it in y equals mx plus b form, no problem. But you could also find the intercepts. Remember, to graph a line, you just need 2 points. And 2 relatively easy points to find are the intercepts. So I'm just going to rewrite my equation here. It was 2x minus 3y minus 12 equals 0. So as I said, 2 easy points to find are the intercepts. The x-intercept along the x-axis and the y-intercept along the y-axis. Now, the x-intercept of a line, if we think about it, all along the x-axis, the y values for all those points are 0. So you guys learned last year to find the x-intercept, you plug in y equals 0, and you solve for x. So plug in y equals 0. Of course, that just wipes out that whole term, and you're left with 2x minus 12 equals 0. Add 12 to both sides. I'm doing this a little quicker than in our solving equations review lesson. This is a kind of equation I would expect at this level for us to be, we can just do very quickly without too much thought, and we get 6. So we get the x-intercept is 6, the point x equals 6, and again, y equals 0 for any x-intercept. And that's exactly what we found out when we graphed it earlier. To find the y-intercept, we do the same thing, but we just plug everywhere. Every y-intercept has an x value of 0, so plug that in. 2x minus 3y minus 12 equals 0. So that's just 0. So we're left with minus 3y minus 12 equals 0. Add 12 to each side, you get minus 3y equals 12. Divided by negative 3, you get y equals negative 4. So the y-intercept is x equals 0, y equals negative 4. Now, if we pretend that we never already graphed this line by finding the y equals mx plus b form, this would be an alternate way to graph it. We found the x-intercept, 6. We found the y-intercept, negative 4. To draw a line, all you need is 2 points, and we would have got the exact same line. So 2 different methods, whichever one you prefer, you can use. All right. So we've reviewed the needs to know, the things that are essential. We have to be able to be proficient at, picking off slope and y-intercept, at graphing lines, and also if a line is not in y equals mx plus b form, we need to be okay with that. We still need to be able to graph it. So I've given you 2 methods. So obviously, I'll have a bit of practice for you with that. But now we are ready to go to start our brand new learning for the grade 10 course. Our first unit is about linear systems. And in our next lesson, we'll learn what a linear system is. So spoiler alert, it involves lines, and to discuss how to solve them. And another spoiler, it involves our solving equation skills. So, but that's for next lesson. In the meantime, guys, I hope you have a great day. Hope you're staying well as also, and we'll see you soon.